Hello everyone and welcome back to Top Tech Gossip with Sana. I'm your host Sana, and today we're exploring one of the most critical and perhaps underappreciated aspects of modern AI infrastructure: GPU clusters. For many businesses, performance isn't just about a brilliant algorithm. It's about having the horsepower to train models and run inferences at scale. And that's where Cyfuture.AI truly shines. Joining me today, as always, is our resident AI expert, Sam, technical lead for AI/ML at Cyfuture.AI. Welcome back, Sam.
Hey Sana, thanks for having me. I'm excited to talk about GPU clusters because they're really the unsung heroes of high-performance AI. They are the backbone that turns theoretical machine learning breakthroughs into real-world, scalable solutions.
Absolutely. Let's start from the beginning. What exactly is a GPU cluster? And why is it so important for platforms like Cyfuture.AI?
Great starting point, Sana. In simple terms, a GPU cluster is a group of interconnected graphics processing units, GPUs, that work together to process massive amounts of computations simultaneously. While GPUs were originally designed for rendering graphics, their architecture is well suited for the parallel processing needed in machine learning tasks. When we talk about a GPU cluster at Cyfuture.AI, we are referring to an elastic scalable network of these GPUs that can be allocated dynamically based on the workload. Traditional systems might run one or two GPUs under fixed conditions, but our clusters can scale from as few as 16 GPUs to over 100,000 cores. This flexibility means that whether you're training a relatively small model or tackling massive billion-parameter networks, the hardware adapts to your needs, all while minimizing latency and cost.
That's incredible. In our previous episodes, we discussed how Cyfuture.AI revolutionizes serverless inferencing and fine-tuning. But when it comes to the heavy lifting of model training, GPU clusters are absolutely essential, aren't they?
Exactly, Sana. Training modern AI models isn't just challenging, it's computationally intense. It often involves running millions, even billions, of operations simultaneously. With a robust GPU cluster, you're not just speeding up the training process, you're making it feasible. For instance, we've seen projects where models that once took weeks to train can now be accomplished in a matter of hours. This is achieved through distributed training techniques that split the workload across hundreds, sometimes thousands, of GPUs. One real-world example. We recently trained a state-of-the-art transformer model with 1.3 billion parameters. On a traditional setup, this might have taken several weeks. Using our GPU clusters, we completed the training in under 10 hours, all while keeping costs efficient with our pay-as-you-go model.
That efficiency sounds like a massive competitive advantage, especially for startups and enterprises that need to iterate quickly. Can you explain a bit more about how these clusters are managed and optimized?
Absolutely. Management of GPU clusters involves a sophisticated orchestration layer that handles provisioning, load balancing, and auto-scaling. At Cyfuture.AI, our platform leverages container-based infrastructure. Think Docker combined with Kubernetes-like orchestration, but specifically optimized for AI workloads. This means that when a new task arrives, the system immediately checks available resources, spins up new GPU nodes if necessary, and allocates the job based on real-time demand. Our scheduling algorithms are designed to minimize startup latency and maximize throughput. We use cutting-edge techniques like automatic sharding, where data is divided intelligently across GPUs, and mixed precision training, which helps reduce the memory footprint while maintaining model accuracy. The result is a system that not only scales efficiently, but also ensures that each GPU is working at optimal performance.
It's clear that behind every breakthrough model or real-time application, there's an army of GPUs working seamlessly. What about reliability and uptime? How do these clusters ensure that businesses don't face downtime during critical operations?
Reliability is paramount. Our infrastructure guarantees 99.999% availability, meaning that even during peak times or unexpected surges, your applications continue running without hiccups. This is achieved through redundant configurations, real-time monitoring, and proactive error detection. Each GPU node in our cluster is continuously monitored, and if any issues arise, the system automatically reroutes work to healthy nodes without any manual intervention. In addition, our load balancing ensures that no single node becomes a bottleneck. This kind of resilience is crucial for industries that depend on real-time data processing. Think of financial institutions executing high-frequency trades or healthcare systems monitoring patient vitals in real time.
That reliability really sets the stage for mission-critical applications. I also recall you mentioned before that Cyfuture.AI supports a variety of GPU models, from A100s to H100s, and even next-gen chips. How does supporting multiple types of hardware benefit users?
Great point, Sana. Supporting a range of GPU models means that our platform isn't tied to a single hardware vendor or configuration. This multi-vendor approach offers flexibility and future-proofing. For instance, some tasks might benefit from the raw compute power of H100s, while others might be more suited to A100s, with their mature ecosystem and established performance benchmarks. By integrating multiple GPU types, we can optimize workloads based on their specific requirements. This means not only better performance, but also cost efficiency. Users are not forced into a one-size-fits-all solution. They can choose the right GPU cluster configuration that matches their budget and performance needs, ensuring optimal returns on their investment in AI infrastructure.
It sounds like Cyfuture.AI's GPU clusters are built with both performance and flexibility in mind. So for someone new to using GPU clusters, or even considering switching platforms, what's the big takeaway?
The big takeaway is that GPU clusters are no longer a luxury. They're a necessity for any enterprise serious about AI. They enable rapid iteration, cost-effective scaling, and the ability to tackle problems that were once deemed too complex. Whether you're training next-gen models, deploying real-time inference engines, or fine-tuning your AI to perfection, the underlying GPU infrastructure is what makes it all possible. With Cyfuture.AI, you're not just getting access to powerful hardware, you're unlocking an entire ecosystem designed to maximize efficiency, minimize downtime, and accelerate innovation. It's a turnkey solution that bridges cutting-edge research and real-world application.
That's powerful insight, Sam. With such transformative capabilities, it's clear that GPU clusters are a cornerstone of next-gen AI. Businesses that harness this technology can truly outpace their competition.
Absolutely, Sana. As AI models and applications continue to grow in complexity and scale, having access to agile, high-performance GPU clusters will be the difference between leading the market and playing catch-up.
Thank you so much for this comprehensive deep dive into GPU clusters, Sam. It's been fascinating to hear about the engineering marvels behind Cyfuture.AI and how they empower businesses to reach new heights with AI.
Thank you, Sana. I'm always thrilled to share how our innovations are pushing the boundaries of what AI can achieve. We're excited about the future and what our customers can accomplish with these tools.
And thank you to all our listeners for tuning in to this episode of Top Tech Gossip with Sana. If you're ready to supercharge your AI infrastructure with state-of-the-art GPU clusters, keep an eye on Cyfuture.AI, because the future of AI is powered by incredible performance and unmatched scalability. Until next time, keep innovating, stay curious, and seize the power that moves you